This video demonstrates an autonomous object learning experiment where the robot arm is used to physically interact with the object so that a stereo camera vision system picks up training images of the object and uses it for training data. And here you see the Puma 260 robot arm, which has 6 degrees of freedom, move out of its cradle and get ready for an experiment. And at this point I'm sitting to the left of the screen behind a computer desk monitoring the real-time output of the system. And the idea here now is that the stereo vision system shown to the top and to the right of the white bottle has identified the white bottle and is asking me for permission to nudge the object. And at this point I tell it, yes, go ahead and nudge an object. And as you can see here, the motion control is quite smooth and quite slow to ensure that the object doesn't tip over. And the white bottle there is actually empty. It might not be clear from the camera view from this far away. And at this point, after the nudge, the segmentation is returned after 80 milliseconds for each camera, and the camera is operating at 1280 by 960 pixels, so quite large images. And now you can see me thumbling the camera trying to show you the real-time segmentation shown on screen. So in these segmentations, the green line is the posterior tracking estimate of the symmetry tracker on the object, so basically the object symmetry line. And the blue dot is the top of the object segmentation. So this is used in stereo to triangulate the height of the object, which is missing after the nudge. So this is calculated, and after this the robot asks me for a permission to grasp the object. The whole idea of the system is that everything is autonomously decided by the robot except permission to do actions just in case there's some sort of occupational health and safety hazard. And now I'm giving permission to grasp the object. So the arm moves over the object and lowers itself with the gripper open and then closes the gripper over around the object. And once the object is lifted, it will rotate the object in 30-degree increments, so collecting 12 training images total over the whole 360-degree rotation of the object. And these training images are used as training data by the robot to build a SIFT database of objects, so that, as shown in my thesis, multiple objects can be learned this way, and then recognition can be performed very robustly because multiple views of the object is obtained. And after rotating, the robot replaces the object back at its original pre-nudged location so that further experimentation can be performed if necessary. And at this point, the learning experiment is completed and the robot has collected training data on its own. So as you can see, the system is quite autonomous and no human intervention in terms of physically manipulating object is required during the entire learning process.